Hi guys, welcome to my YouTube channel. In this video, I'll walk you through how to use the Keras functional API. Let's take a look at the topics we will cover in this video. First, we will briefly discuss what the Keras function API is. Next, we will load the dataset and perform data preprocessing. After that, we will learn how to build a model using Keras function API. Finally, we will handle how to make predictions. Let's move on to what the Keras function API is. The Keras function API allows you to easily build models that are more flexible than the Keras sequential API. You know, deep learning models consist of layers. So, the function API is a way to build graphs of layers. Cool! We briefly discussed what the function API is. Let's take a look at how to use this API. For this, let me go to Google Colab. Before using Colab, first let me set GPU. Click Runtime, change Runtime. After that, let's choose GPU. To do so, we can train our model faster on the GPU. Okay, we set the GPU. To learn the functional API, we will deal with a regression problem. Let's move on to load the dataset. The dataset we are going to use is the California housing dataset. This dataset contains 8 features. All features are also numerical features encoded as floating numbers. Let's load this dataset with scikit-learn. To do this, we are going to import the fetch California housing function. Let's write from sklearn.datasets import fetch California housing. Now let's load the dataset with this function. Let's type housing equal fetch California housing. Nice! We loaded the dataset. Let's split the dataset into training and test sets. To do this, we can use the train test split function. Let's import this function from sklearn model selection import train test split. Note that we build the model with the training set and evaluate the model with the test set. Now let's create the datasets x train, x test, y train, y test equal. Let's write train test split. After that, let's type input data, housing data, and then write the target variable, housing target. For random state parameter, let me set 42. Cool! The dataset is ready to build the model. Let's move on to build the model. So far, we loaded the dataset and then created training and test sets. Now, let's handle how to build the model with the Keras function API. To show this, let's import TensorFlow. Import TensorFlow STF. What we are going to do now is to set TensorFlow's random seed to make the result reproducible. To do this, let me write tf.random set seed. Let's set 42 again. Before we train the model, let's create the layers that we will use to build the model. This is the model we will create. As you can see, the model consists of 2 input layers, 2 normalization layers, 2 hidden layers, a concatenate layer, and lastly, an output layer. Great! We've seen the architecture of the model we are going to build. Suppose we want to set 5 features through the wide path and 6 features through the deep path. Let's start creating the wide input layers. Input wide equals tf keras layers input. Let's set the shape parameter to 5 features. Shape equal 5. Nice! We create the first input layer. Next, for the 6 features, let's create the second input layer. Input deep equals tf.keras layers dot input shape equals 6. Cool! We create the second layer. Let's go ahead and create the normalization layers. These layers work like standard scaler in scikit-learn. These layers help us scale data. Since we have 2 inputs, let's create 2 normalization layers. Norm layer white tf.keras dot layers dot normalization. After that, let's create second normalization layer. Norm layer deep equals tf dot carries dot layers dot normalization. Awesome. We create the normalization layers. Note that to use these normalization layers, we need to call the adapt method before calling the fit. Now, let's pass our inputs to these normalization layers. Norm white equals norm layer white. Let's set input white. After that, let's write norm deep equals norm layer deep. Let's set input deep. Note that data passing through the white normalization layer goes directly to the concat layer. The other data passing through the deep normalization layer goes to hidden one layer. Now let's create the first hidden layer. Hidden one equals tf dot carries dot layers dot dense 30 for the activation parameter equals relu. Let's give the norm deep variable to this hidden layer. Norm deep. Next, let's create the second hidden layer. Hidden 2 equals tf dot carries dot layers dot dense. Let's set 30 for the activation parameter equals relu. Let me fix this parameter name. After that, let's give the output of the first hidden layer to this hidden layer. Hidden 1. Cool! We've created our hidden layers. Now, let's create a layer to concatenate the data passing through the hidden layers with the data passing through the wide normalization layer. Let me set concat equals tf dot carries dot layers dot. Let's type concatenate. Let's pass two layers. Norm white comma hidden 2. Nice! We also create the concat layer. Now let's create output layer. Since our problem is regression, we are going to set a neuron in this layer. Let's write output tf dot carries dot layers dot dense. Let's set 1. After that, let's write concat as input to this layer. Concat. Awesome! We created our all layers. Now, let's create our Keras model and pass the inputs and outputs to it. Model equals tf dot carries dot model. For the inputs parameter, let me set input white and input deep. For the output parameter, let's pass output. Okay, we create the architecture of our model. We can show the input and output shapes of each layer in the plotted graph. Let me show you this. tf dot carries dot utils dot plot model. Let's type model. Let's name my model dot png. For the show shapes parameter, let's set true. You can see the architecture of our model in this figure. Let's move on to compile the model. Before training the model, we need to compile our model. While compiling, we specify a loss function, an optimizer, and metrics we will use. First, we specify our optimizer. Let's write optimizer equals tf dot carries dot optimizers Adam. Let's set learning rate. Give the number. It's time to compile our model. To do this, model dot let's call the compile method. For the loss parameter, MSE mean squared error. For the optimizer parameter, let's set the optimizer variable. For the metrics parameter, let's set root mean squared error. Cool! We compile our model with the compile method. Now let's create our input data. To do this, let me assign the first 5 attributes to a variable and the attributes after 2 to a variable. First, let's create our training dataset. Xtrain white xtrain deep equals xtrain colon comma colon 5 xtrain colon comma 2 colon. Next, let's create the test datasets. X test white x test deep equals x test colon comma 5 colon x test colon comma 2 colon. Next, let's use the adapt method to find the mean and standard deviation values that we will use for the normalization layer. Norm layer white adapt xtrain white. Let's do the same for xtrain deep. Norm layer deep dot adapt xtrain deep. Let's train our model by calling the fit method. Let's write history equals model dot fit. Let's write the input data xtrain white xtrain deep. Let's set the target data y train. For the epics parameter, let's set 20. To use validation data, let's use the validation split parameter. To do this, let's write validation split. Let's set 0.2. When we run these codes, model training starts. At the end of each epic, the loss and evaluation metrics are calculated. We see that loss values are decreasing. This means that the model learns from the data. Okay, model training completed. Now we can evaluate our model on the test data. For this, let's call it the evaluate method. Test scores equals model dot evaluate x test white x test deep. After that, let's set y test. We got error. Let's fix this. After that, let's run this cell again. Awesome. Here you can see the loss and metric values. Now, let's take some data from the test dataset and evaluate this data according to our model. X new white x new deep equals x test white colon 3 x test deep colon 3. Okay, we got our sample data. Now let's predict this data according to our model by calling the predict method. Y pred equals model dot predict x new white x new deep. Let's take a look at this variable. Okay, we've made the predictions of the data. We can also see real labels. To do this, let's write y test colon 3. Here you are. That's it. Thanks for watching. I hope you enjoyed. You can find the link to this notebook in the description box below. Don't forget to subscribe to the channel and hit the bell icon so you don't miss the latest content about AI and data science. You can also follow us on the other social media accounts. See you in the next video. Bye for now.